Hello, welcome to JFocus. I'm Holly Cummins. I'm a consultant. I'm an IBMer. I'm a consultant in the IBM Garage, and I'm a developer. And I think all of us were so lucky to be developers in 2020. We have such great jobs, and in particular, I think the cloud makes our jobs just so much easier and nicer and more fun than they used to be. A whole bunch of things that were really hard work before, like provisioning machines, like patching machines, that's just kind of gone away and become easy and nice with the cloud. But of course, that doesn't mean the cloud doesn't have its challenges. A lot of us have at one point or another been kind of electrocuted by the cloud. And I think the reason for this is that there's just new skills that we need in order to really work well in this kind of cloudy environment. So in 2020, that we've got to be good at hand washing. That's nothing to do with our jobs. That's just 2020. But as devs, obviously we're going to be writing apps. There's more of us are probably going to be full stack than used to be the case. So that we sort of need to know the front end and the back end and a whole bunch of other skills there. But as well, we've got to be good at ops now. We can't just throw things over the wall and let it be someone else's problem. We need to know how to run these things in production, and that's new skills. And of course, once we're doing the dev side and the ops side, then we're doing DevOps. And so this is something that we've got to get a grip on. And once we start doing DevOps, then security say, what about us? That matters. And yeah, security matters a lot. So we've got to be doing DevSecOps. And then the business say, well, but surely we matter. We're the sort of the most important part. And yeah, so then you get into DevSec, BizOps, and then you get into design ops. And I won't go into all of the ops. There's a lot of them. But I do want to talk about FinOps because I think that's going to be increasingly important in this cloud environment. So why did some of us get electrocuted in the cloud? I think it has to do with the fact that the cloud just turned a whole bunch of things upside down, and there were habits that we had, things like how we did our logging, that were really good ideas before the cloud, and then they became really terrible ideas. And one of the things that's different in the cloud is how we manage our applications. So the beauty of the cloud, the joy of the cloud, the thing I love about it so much is it makes it so easy to provision hardware. It's just this frictionless experience. But of course, that hardware is still hardware. So just because it was easy to provision doesn't mean it's free. It's still running on a system somewhere. And it doesn't, just because it was easy to provision doesn't mean it's actually useful. And just because it's easy to provision doesn't mean it's easy to turn off. We still need to manually go and turn these things off. And the reality is, a lot of us forget. So when I was first learning Kubernetes, I tried it out, as one did, of course. So I created this cluster, but I had too much work in progress. So I got pulled away, and it was 2 months that I was pulled away. And so then when I came back to it and looked at this cluster, I realized it had been running for 2 months, and I'd done a pretty well-spec'd cluster. So it was €1,000 a month that had just been burnt. And that's kind of sad. And our industry, we have this problem with zombies, which is things that maybe were alive and useful once, but then they sort of shuffle along in this undead state, and they're not useful. They're taking resources, and it's really, really surprisingly hard to fix. I get sort of these, pleading emails saying, can everybody please remember to turn their servers off? And, if you do an experiment, tag it appropriately so we can find it and, hunt down the zombie. But we don't really have super good automated ways of dealing with this yet, or at least not at a sort of an industry standard level. And it's not just me who has this problem. This is a problem that we have, I think, probably all of us. So there was a semi-academic survey that was done in 2017, and they looked at around 16,000 servers, so a pretty good sample size, and they found a quarter of these things were doing no useful work. So then the question is, like, how did this happen? Was it malice? And their best guess was no, people just forgot to turn these things off. So this is a whole new skill of like hunting down the zombies, getting the right habits that we need to get good at. And the hope, of course, is that eventually we don't have to be doing this manually, because doing things manually is annoying. So this is where FinOps comes in. So FinOps is the discipline of, really it's about cloud costs, and it's trying to get clever automated ways of making sure that cloud costs flow to the right part of an organization, so that if you have one big cloud instance and one department's using way more than another one, that cost does flow appropriately. But what I really think FinOps is going to be most useful for is figuring out who in your company forgot to turn off their cloud. And because we need that technological help there, because this is too hard a problem to be able to handle manually. Releasing is another thing that's become super different in the cloud. So it used to be that the way we released software was we did a death march to the deadline, got as many features in as we could, and then did sort of a manual period of testing. And then we sent the software to Dublin, where it got put onto CDs, and then it got shipped out to customers. And of course, putting things onto CDs is expensive, so you can only do it occasionally. And so it meant we had these sort of huge deadlines, and there was a release schedule, and that release schedule did not change. And this is how we worked as an industry. And there was a whole bunch of bad things. One was that there was this, there was so much pressure on the features that it put pressures on the team. So it wasn't a very humane environment. And then there was so much pressure to get the features in that I think it put downward quality pressure on as well. Whereas if you go on more of a continuous release cadence, which is what the cloud allows, you don't sort of have these big waterfall periods of testing. And paradoxically, your quality is also higher. So that, I think, is a really positive thing about the cloud. And I spoke to a bank, and they wanted to move to this more modern release cadence. But the thing about it is, it's not just about your software, and it's not just about your architecture. It's about how you structure all of your internal governance. And you have to change that internal governance, because things that used to be a good idea are no longer a good idea. So this bank, they were sort of getting eaten alive by their competitors, and they knew they were moving too slowly. And they looked at their architecture, and they had this big COBOL estate, and they said, we've got to modernize this. We've got to move to microservices, which may have been the right thing to do. But then they added, our release board meets twice a year. And so if your release board only meets twice a year, it doesn't matter how many microservices you have. It doesn't matter how beautiful that microservices architecture is. You're only going to release twice a year. So maybe microservices aren't going to fix the problem you think they're going to fix. And we think of microservices in terms of helping us with our release cadence. And of course they do, because microservices can be released independently. And that's one of the great things about them. But the core problem that microservices are addressing is modularity. And that is a problem we've been trying to fix in our industry for 60 years. I think it's one of the oldest problems in computer science. And it's such a hard problem because we're trying to do two opposite things. We want our system to be a big system so it can do something non-trivial. And the parts of that system need to communicate with each other, because otherwise it's not a system. But as soon as they communicate with each other, they're coupled. And as soon as they're coupled, we have all sorts of problems that come from coupling. So we have a brittleness, because changes in one part of the system can break something else. We have an overhead that comes with managing that coupling. How do I communicate about changes? How do I allow teams to make good changes, but not allow them to make breaking changes? And so there's been a bunch of solutions to this, but all of them, including microservices, I think aren't perfect because the problem is so fundamentally hard. And when we think about microservices as, microservices are a technique for managing coupling and for enabling a really rapid release cadence, but they're not a goal in themselves. So when we need to step back and think, well, what problem am I actually trying to solve? Am I trying to manage my coupling? Am I trying to go faster? Am I just trying to get more team autonomy? And all of those are good, but microservices are a means to get those goals. Microservices aren't a goal in themselves. And that is despite the fact that Netflix are an awesome company and do microservices. I think we sort of get into this habit of wishful mimicry where we look at what microservices or at what Netflix do, which is so oriented around microservices. And we say, if I do microservices, my engineering will be as outstanding, as excellent as the Netflix engineering. But of course, there's a whole bunch of conditions in place for that. It's not just the presence of microservices. And in fact, Netflix have their own domain and their own context. And that context isn't the same for every institution. So a lot of the problems that Netflix are solving, other organizations don't have. And so microservices may not make sense. And it is totally possible to do cloud without doing microservices and to do cloud well without doing microservices. And it is even possible to be cloud native and not do microservices. Those aren't synonyms. And microservices do come with problems. So I was called into a project, and the reason they asked for help was that they had this microservices architecture. And every time they touched any microservice, all the others broke. So this was the opposite of decoupled. And it wasn't what they actually had, although they didn't really realize it. It was a monolith. It was just that the communication within that monolith was distributed. But it was a big pile of spaghetti. And the distribution made it worse because it meant that if you called another function, it was in a different process, so you didn't know if it was going to be there, if your call to it was going to execute properly. You didn't get that compile time checking that Java gives you, that type safety that Java gives you. And so they had this sort of spaghetti, and it just got more and more spaghettiful, and then it started having more and more damaging impact, and then it sort of started sending tendrils of spaghetti out everywhere. It was not good. And the fundamental fallacy was this assumption that if you're distributed, you're decoupled. But distributed and decoupled are not synonyms. You can be very distributed and yet very coupled. And you can be running in a single process and yet actually be quite modular. So something like OSGI, for example, enables beautiful modularity within a single process. So there's all sorts of good reasons not to do microservices. If you're a small team, you don't have that communication overhead between teams. So then microservices aren't going to save you that. If you have no plans to release these things independently for business or market reasons, microservices aren't going to give you that benefit. When you think about microservices, they have to communicate with each other. They have to find each other. They have to handle security between the microservices. And all of that can be handled quite well by a service mesh. But I think sometimes we think, oh, no, I don't want a service mesh. I just want to do microservices. So then we end up rewriting the capabilities of the service mesh ourselves. And at that point, we still actually have a service mesh. It's just that one that we have to maintain. So not necessarily so good. Another strong reason not to do microservices is if the domain model doesn't have these neat seams, then maybe it shouldn't be in microservices. And that turned out to be the problem in that big pile of spaghetti. There was a quite complex data model, and it had about 20 classes, and there was about 70 fields on some of the big classes. So there was a lot of data, and it was common across every single microservice. And so when I looked at the code, I saw all this duplicated code, and that's not necessarily a bad thing. But I said, why hasn't this gone out into its own library? And the answer was, well, we don't want the coupling of having that common library. So instead, we're going to copy and paste the code around. But of course, there still was that coupling. If a field name changed, it broke everything. So with microservices, how it's supposed to be in the sort of the ideal scenario is that you have a whole bunch of microservices, and each one maps really neatly to a quite distinct domain. But what had happened in this case was there was one domain for all of those microservices. So even though they were doing functionally different things, because the data model was so common, it meant that they could never really be decoupled. So everybody always says, and they're totally right, if you're going to do microservices, you need to get really good at automation. The other thing that you need to get really good at is testing. So when we think about testing, it's useful to think about it in terms of the test pyramid. So at the top of the pyramid are your integration tests. Those give you great confidence that the system works. Those are closest to the end user experience. But they're really expensive to write and they're really expensive to run. And so if you have a system with 500 microservices, you are not going to stand 500 microservices up on your laptop while you're developing to give you confidence that it works. You just can't do that. So at the other end of the spectrum, we have the unit tests. Those are cheap to write, they're easy to run, you should have a lot of them. They are the foundation of your product quality. But they have a small problem, which is that they don't necessarily give you great confidence that things actually work. The assumptions that get baked into unit tests may not be correct. And so if those assumptions are wrong, the unit tests will all be green and the product won't work. So at the middle, we have what's called contract tests. So contract tests test the seams within your product. And there's a couple of popular frameworks. Spring Contract is one, Pact is another one. With both of those, one of the things that I really like about them is that they support test-driven development. So you can do TDD at the unit test level, you can use your integration tests to test drive things, and you can definitely also use your contract tests to test drive. So if you think about how to test a fire alarm, I have a strong recommendation for how not to test your fire alarm, which is this. It gives you great confidence that the fire alarm works, but the building is on fire. You hope that someone tested the fire alarm like this at some point, but I'm not going to do that with my fire alarm. Instead, what I'm going to do is my fire alarm has this little button that says test, and once a week I can push that button, it makes a beep noise, and I know that the fire alarm is capable of making a beep. But of course, I care about more than the fire alarm making a beep. I want the fire alarm to go beep when there's smoke, not just when I push the button. So this is where the contract tests come in. You can get these things, and a lot of institutions use them, and they're like a contract test for a fire alarm. So it's like a cup, and then that cup is on a stick, and you can you wrap it, you sort of cup it round the smoke alarm, and then it sort of blows in smoke, and then you're testing that condition of when there is smoke, does the fire alarm go beep, without the trouble of actually setting the whole building on fire, which I think we can all agree we don't want to do. So it's a great thing. And so we can do similar things in code. So let me just I'm going to show a little bit of Pact. So I've got a quite a simple application. If you're paying a lot of attention, you will notice that I've got a BFF, which I'm running in Eclipse, and I have a front end, which I'm running in Node.js. You may say, yeah, that sounds like a pretty standard architecture. That doesn't sound like microservices. And it's true. I didn't want the trouble of running 16 microservices on my laptop while I was trying to do a demo, and the problems that you get when two things communicate, you can show with just two things rather than a lot of things. So I'll show you what my application looks like. So I have at the back end, the the mental model, or rather the actual model for this application, is a person going around rooms of a house. And so all of the rooms happen to be in that same monolithic BFF, but they could be that each room was a microservice. And I could be as well that I need to go outside the house. So if I need to go to the hairdresser, my person is going to go to the hairdresser, and that's going to be outside the house. So that might be, for example, in a different language that's not Java. And if I want to reduce the sort of the surface of my data model that gets shared from microservice to microservice, I could, for example, send just the head to the hairdresser. Obviously, doing that with a real person would be highly illegal and quite gruesome. But you know, in data, the hairdresser only needs to see the head. And one of the other things about this model is that different rooms will have different paces of change. So, for example, a kitchen, you're only going to want to change a kitchen every 10 years because it's so expensive to remodel a kitchen. Whereas the living room, you might get new throw cushions, that kind of thing, on quite a regular pace. And so you don't want to have to wait to remodel the kitchen before you can redecorate the living room. So there's that requirement for the different paces of change. So you can see at the back end, I've got some JSON coming out just of the different body parts, and each one has a state. And then at the front end, what happens is that the person will move from room to room in the house, and the state of their body parts changes as they go from room to room. So they wake up in the morning and their hair is like that, and then they sort of go downstairs to the bathroom, the hair gets combed, they go to the kitchen, they get a bit fat because they've eaten, and you can sort of see it going round. So what happens if I want to change something? Because if I look at this data model, I'm talking about the torso, and that's kind of a complicated word. So I'm going to rename that. So if I go to my resident model, I've got this torso, and let's refactor and rename that to stomach. So now what I should see is my IDE, because this is all in the same project, in the same application, my IDE has done the right thing. It's used that compile time checking, and when I changed something in one class, it went through the whole code base and it updated everything automatically. So now instead of having a torso.class, I have a stomach.class. So what happens if I go back and look at my JSON? My JSON hasn't actually changed. And that's because if I look at my resident, I'm using JAX-RS to handle all of the REST communication. And the thing that returns the stomach is called getTorso. So let's fix that. So let's call it getStomach instead. So now, if I go back and I look at my code, sure enough, I have a stomach and it's in state hungry. Cool. Successful refactoring. So let's look at my end-to-end application. So let's reload this guy. It's missing a stomach. And you can see what's going on is in this table. This table doesn't really have any kind of dependencies, and so there it's called stomach. But for the visualization, there is a bit of a stronger coupling, because in order to find the right image file, it needs to know the name. And the name has changed. And when I changed the name, I didn't go and talk to the front end team and say, by the way, what dependencies do you have on my data model? I just thought I was making it better. So things are broken. So this is where contract tests come in, because the really sad thing here is everything is broken, but all my unit tests are passing fine. So my Java unit tests are passing fine, and here I've got my Node.js tests, and they're passing fine as well. So I'm going to add a contract test. So if I go to my source, I have this resident table test. That's a unit test. And I'm just going to change it round, and I'm going to call it .contract test. And this is one of the nice things about the contract testing is it can be a really good complement to the unit tests. So when I was writing this demo, I did actually start with a contract test, and I used them to test drive the application. But as it went on, of course, they're way cheaper than integration tests, but they're still not as cheap as unit tests to run. So I would want more unit tests. But for both of them, there's this expected result. And so I can share the assumptions between my unit tests and my contract tests. And that means that if my contract tests are passing and my unit tests are passing, I've got pretty good confidence. So I've just got this expected result, which is that. So now in my contract tests, I need to do a few other things. So I need to change out my mock and replace it with the packed mock. So when I run a consumer test, one of the things that the packed framework does is it gives me a mock, and that is why I was able to use it to test drive. So I'm not going to live code the whole thing, but I will show you the difference between the unit test and the contract test. So here, I bring in a bit of packed stuff. I do a bit of packed setup. What I'm doing here is I'm using some regular expressions rather than just the base data, but I also do say when it goes and gives the mock to the test, this is what you give it. So I've got all of that, and then my test body is exactly the same as it was in the unit tests. And again, probably you wouldn't exactly cut and paste between the two, but it's sort of convenient for showing that the basic test ends up being very similar to what you would write. So if I pull back what I had in source control and I run my tests, what I should see is that my tests all pass. So you think, well, what was the point of that? And it has to do with the assumption. So when my tests run, what they do is they create this file, which is the contract. So it creates this contract, which describes all of the interactions that are going to happen. But I haven't actually shared that with the provider yet. I haven't shared it with the backend. So what I need to do is I need to do two things. First of all, I need to go and I need to pass that contract. I need to pass that expectation to my backend. And how you normally would do that is you'd have your build pipeline check it into the provider's source control, or you'd use what's called a packed broker. So a packed broker is a server that's going to run, and it can show you the latest status of the tests. You can see your dependency graphs. It does a whole bunch of cool things. I'm just going to do it low tech, so I'm just going to copy my contract from the front end to the back end. Whoops. I'm going to copy it into the right place. Okay. Gonna copy it into the right place. Cool. So I've copied it across. So now I need to do one more thing, which is to actually write the test. So again, if I look at my differences, I've got this house contract test. There's a whole bunch of imports, but the actual test itself is really small. So I declare my provider. So I say this is a test of house, and I tell it where to find the contract. I've got a bit of before each, which tells it where to find the server. So this is, it has to run against a server, so the server has to be up before the tests run. So it's a bit different from a unit test in that way. But then the meat of it is just this test template, which says basically for every interaction in that packed contract file, please validate the interaction. And it can do some really powerful interaction. So it's actually a really useful way of testing your code. It's not just about making sure that the expectations are matched, because it will say, it's testing more than just the syntax. It will say, you can say things like, if I call this endpoint and I pass in hair, I really expect that the hair comes out, has the sort of the shape like this, but that the hair state is frizzled, because the bathroom takes the hair from not frizzled to frizzled. So you can, it's actually, it's a way of writing tests for your provider with, as you can see, very little code. So if I pull this back from source control, and if I go to my Java, I have this test and I can run this test. And you can see it will fill in a bunch of code, and it's going to say, look, I expected there to be a torso, and instead there's a stomach. So I've got that successful failing test to show I have a problem. So I could put everything back or change the contract, but I think you can see the point is that I broke it, and now I have a test with fairly little effort, which is showing that it's broken. So really, just to sort of to conclude, if you're doing microservices, those contract-driven tests, consumer-driven contract tests are fabulous. And with that, I'll stop. So thank you very much. Please do rate the talk, and I'm looking forward to questions.
So with that, we arrive at the Q&A part. So Holly, if you would be so kind. So I think you wanted to ask the audience a question first, right?
I did, yeah. Thank you for the reminder. So I had a few polls, so I thought we could try them out. So the first one really is about people's experiences of contract testing. So I know, I think they're not super widely used, and some people have had some interesting experiences. So I'm interested to see where we are in the room. Okay, cool. Yes, that's looking healthier, isn't it? So we've got about 10% are advocates of it, think it works really well. 20% of us have never heard of it, and about 60% have heard of it but never tried it, which I think is probably about what I expected. I think one of the problems that I see with Pact in particular, but I think probably with all of them, is it is confusing. So when you get started, I've seen people sort of end up testing the mocks rather than testing the code, and it's sort of easy to get drawn down that path. So yeah, these numbers are staying fairly consistent now. Cool.
So that was the one poll you had, or did you have another one?
I did have another one. I don't want to just sort of sit and play with polls. If there's
okay,
questions.
no, that's fine. There's some question as well.
Yeah.
So there was one question earlier about the domain model, and when it doesn't split up nicely, isn't it just a matter of putting more work into it to discover the boundaries? Could you elaborate a bit on that?
Yeah, I think there's probably sort of two possible answers to that. One is, yeah, you're right. Those domain boundaries are easy to get wrong, and that's sort of one of the challenges of microservices, is that if we get it wrong, we've got the wrong domain boundaries, and we need to do some fairly serious thinking and work at the beginning to get the domain boundaries right. Another answer is, well, yeah, but maybe sometimes the optimum domain boundary is actually the one that's all the way around the whole solution, and no matter how much work you put in, there just isn't going to be that neat division. That neat division. My life has just been summed up. that there isn't going to be that neat division. And then maybe there's sort of like a middle ground too, which is if you had a lot of time and had access to the right domain experts, you could get the good boundaries, but actually life is too short and there's too many other pressures, so maybe just leave it as a big thing. That's the pragmatic thing to do.
Right. And another question was, does it really matter where one starts, consumer or producer, as long as it can be a round trip?
Yeah, I think that's a really great observation. So it's always called consumer-driven conflict tests, and the idea, the sort of the theory is that the consumer does it and gives their expectations to the producers. I think the other way around is probably more likely, which is that the person who really wants to test drive their code and to validate what they're doing is right, and the person who maybe starts first is going to be the producer. And then I think probably so yeah, I think either side can start, and maybe the healthiest is one where there's sort of a zigzag back and forth. So the consumer probably has the idea before the producer has the idea for what they're going to write before the consumer does. So they start it and they make sort of a skeleton contract and they say, I'm going to cover these 3 conditions. And then the consumer goes and says, this is great. I can now test drive my implementation using that contract. Oh, but you missed out this condition, this condition, this condition. So they add a lot to the contract with their expectations and then they give it back to the producer side. The challenge is each time it sort of goes back and forth, that has to be managed. And there may be a period where the two go out of sync. And then like one thing that some people find is either you manage versions the contract so carefully that the build never breaks, which is great. If things are in the field and they're broken, then having a green build is a problem. Or you go too far the other way and the producers are sort of trying to work away and then the consumer just keeps like adding new stuff to their contract and breaking their build. And they're like, but our stuff is fine. It's you who have the problem, but you broke our build. So you sort of, need to negotiate that between the teams.
Yeah, I understand. So there's another question about that it looks like syntax testing, but not really semantic testing, because it's basically matching outputs. And can it do more complex checking?
It can, yeah. So you get stuff like there's a Swagger one that I forget what it's called, but basically it's a little wrapper around Swagger. And what you get with Pact is a lot more than that. So you can definitely check like the syntax, but on the consumer side will be quite a useful mock. So you can look at the actual input and then send a specific output back. So you can use it to really drive your code. And on the producer side, it's the same thing. You might test the same endpoint, but you might pass in like 6 different inputs and expect 6 different outputs. So you are actually checking the semantics, not just the syntax.
Okay, right. So time for last question. How does Pact integrate in a CI/CD pipeline like Jenkins?
So it's just a question of invoking it, and then you can also upload the broker. So you'd either invoke it and upload to the broker, or you'd invoke it and then send your contract across to your friend's pipeline.
Right. Thank you very much. Thank you very much for the awesome presentation and the Q&A. It was really nice having you here. And also, thank you very much to our audience, and enjoy the rest of JFol.